right? So what is a workflow of building Linux? So in this flow chart, as I shown in this flow chart, what is a workflow of build root, how we can develop the embedded Linux by using build root. So first step is we are going to download the build root from the official website. Later, we are going to choose the required features in the kernel by using make menu config or make def config for a particular Raspberry Pi board. Okay, so build root is a generalized tool which can be used for any development board like BeagleBone, like Emu board, or any Raspberry Pi board. So it is generalized for all the target boards. But in this, which board we are using? For example, here in this session, I may use it for the Raspberry Pi board. So for that board only, I want to configure by using make command. Okay, make menu config. So for example, def by using def config, default configuration can be given by the build itself for a particular target board. So I want to change some of the options, I want to change some of the features I need to include. Then I may use this make menu config command. Okay, so after selections, that configuration file can be saved, and after that I can cross compile by using the make command or make utility. So whereas make is a base command which can be used for the building building the embedded Linux. Here, build out automatically downloads packages. Whenever I choose this make command, then as soon as I'm giving the make command, which will download all the necessary files and packages from the website directly from the internet, automatically it can be downloaded, and all the other scripts also can be run, and all the modules can be installed. Okay, so that which will make the image of the embedded Linux operating system, which can be the bootable image, which can be the ready for booting the embedded system. And we can copy that image onto the SD card by flashing technique. So by copying that embedded Linux into the Raspberry Pi board, we are going to use the SD card. Okay, so that with that SD card we are keeping in the slot, and we are going to give some power. Then embedded system, that means Raspberry Pi board is running with embedded Linux. This is the workflow of build system using build root to make the embedded Linux for Raspberry Pi board. So what are the prerequisites are required for building the embedded Linux system using build root? Okay, so here in the host PC, that means laptop or desktop PC, which contains the Linux with free disk space. That means the disk space should be the empty. That means whenever we have 500 GB hard disk, in that 15 GB is required to develop this embedded Linux in our laptop or desktop PC. So, and second one, we are compiling entire operating system. The final result is so small. As I told that 150 MB only, final image size. But it needs lot of space to get the things into the system. So it takes minimum 2 to 4 hours of time to building the embedded Linux operating system by using some steps. Okay, so here we are using Raspberry Pi board as target hardware board. So here I may use the 8 GB SD card instead of hard disk. In order to develop the embedded Linux, in order to port the operating system into the Raspberry Pi board, I may use the SD card, which can be the minimum size of 8 GB SD card I may going to use. And next one is working knowledge of some working knowledge of Linux is required in order to build this embedded Linux. Little knowledge is enough. Okay. So these are the some of the tools we need to install in your laptop. Okay, so what are the tools here? I described it as Git. Git is nothing but GitHub. Git is one of the repository that is a remotely controlled system. That means these are the build. We can this is an open source tool. We can use it for all the our industries. They may use this Git repository tool. So from this Git repository tool only, all the softwares we can freely download and we can utilize. Okay, so a compiler will be needed. That compiler will be the mostly GCC compiler. Why? Because all the kernel related files, as I told that kernel file related files are written in the C language. So GCC compiler is required in order to run the applications. In order to make the applications, GCC compiler is required, and some of the miscellaneous tools are also required. And here one more terminal, minicom terminal is required in order to, so whenever we doesn't have any GUI, only command line interface is possible, then minicom terminal is required. So minicom terminal, that is it is nothing but serial console utility that will use the FT2232 serial adapter. That means USB to TTL UART transmission converter is required to communicate with a Raspberry Pi board with my laptop. I'm using this FT2232 serial adapter I'm using. So before going to use this serial adapter, I should install this minicom also. By using this command sudo apt install. So here I using the command in order to download all these things. Within a single command, I may use sudo apt install. Sudo is nothing but all the permissions I need to give. All the administration password is also I need to give. Sudo apt install -y git build essential wget cpio unzip. That means for untar zip files are there, no? So in order to untar, so rsync bc lib encurses 5 dev minicum. So that means individual, whenever space is there, these are the individual tools I'm downloading from the internet itself. Okay, 1 second. So here this is a Linux terminal which is used in the host PC. Host PC means my laptop terminal. So in Linux, I may write the programs here. I may develop the embedded Linux by using the terminal only. So here I'm using so I'm creating one directory. So for example, so this is my CD. CD means change directory. Here I want to create one more folder on the name of FDP. Okay, so FDP embedded system or else FDP ES. I created one folder. So mkdir is a command to create a folder. Okay, so I am going into the folder by using the change directory cd FDP ES. Okay, FDP on embedded system. So the name I should give it as FDP ES. Okay, so in this I should use this commands. So I'm copying this command. Already I installed, but I'm showing this one more time. Sudo means some permissions it may ask. For example, I'm entering the password. As I already installed previously, so it takes less time. Otherwise, it may take 2 to 3 minutes. Okay. So next one is the tool chain. So tool chain related files also we need to download from the internet itself by using this command. So here also some of the tools, Python 3 is also will be needed by bin utilities. That means we are using make command. We are building the embedded Linux. Hence make command we are using bin utilities, GCC compiler, G++, bash, patch, ggip, bgip2, Perl, tar, cpio. Some of the scripts also it may use while developing the embedded Linux. Hence all the things we are installing by using this sudo apt install command. Apt install is nothing but is the command used for the installation in our host PC. But here we are using the sudo. Sudo means permissions. Permissions with the permissions only we need to install. So all the toolchain related files are also will be installed here. So build root. So build root is available in the official website name is https buildroot.org download.html. So in this build root is nothing but which is a build system to which is a tool for to develop the embedded Linux. So here build root recent version is released, that is 2024. .gz file we can download or .xz files also we can download. Okay, so for example .xz file I'm downloading here. So you can download by using graphical selections or you can download by using the command line interface also we can download it. Okay, so build root 2024 0.02 tar.xz. Okay, so tar.xz means here the two files are available, gz files tar.gz and tar.xz also available. But what is the difference in the gz files are as well as xz files? The gz files is faster, especially in older computers, but the resulting files are bigger. Okay, xz takes longer to extract the all the files. It will take longer time, but which will create the very smaller files. See this example, ggif folder contains the 7 MB. Okay, whereas .xz file will do 2024, it right. Here I downloaded both and I see the difference between the images size. So which is of very so xz takes the lesser space when compared to the gz file. Okay, so the gz folder I downloaded and I can download it by using the command line also. So by using this I can download wget https buildroot.org downloads buildroot 2023 02.8 tar.gz. Okay, so here 23 also we can port, and 24 latest release also I can port. Okay, so by taking this one, so tar dot, so you know to extract the command, so I download it from the downloads place, recently downloaded, right? So this will be the recent downloaded one. I'm copying the home I created as fdp, yes, right? I'm placing this one and renamed it as,
ఇంట్లోనే ఉన్నాడు యాక్చువల్లీ.
pardon, am I audible? Okay.
Audible.
Okay, so I'm extracting the file tar minus xf. So the file name starts with build, right? Earlier only one folder is there, that is the zip file, but I'm extracting by using this tar command. Okay, so now I'm going to I'm changing the directory into the build folder. So bui, I'm giving the tab space, so it is giving us full name. Okay, so ls, so it contains the different folders, right? Just you observe this one. Are you able to see the screen, or else I can maximize? Is it clear? Architecture folder, boot folder, board folder, configs folder, docs folder, file system, Linux, package, system, support, tool chain. So as I told that it will create the tool chain also, right? Build it itself. When we download it, it contains all the folders, necessary folders inside the tool chain. So whenever we are making, then only we can get the all the tools. Okay, so toolchain is also available. So I'm going into the folder of board. That means build root supports what type of target boards. So if you see the boards, so you can observe this one: arm boards, beagle bone. Beagle bone means which is the way where it contains the arm cortex processor, right? Beagle bone, beagle bone AI. That means machine learning. It supports the AI also. And here Broadcom board, this which is nothing but SOC. Whenever we are directly SOC, SOM modules we are using for the embedded Linux development, then we can also use this build root for the that boards also. And here it supports all the variants of Raspberry Pi 0, Pi 0W, 2, 3, 364, 4, Raspberry Pi 4, Raspberry Pi 4 64. That means here Pi 3 means 32 bit. Pi 3 64 means 64 bit. Okay, which contains a 64-bit register, 32-bit register, or the 32-bit OS, which can supports, right? So whenever we are selecting any particular board, I can have the in my hand, I have the board called as Raspberry Pi 3. Okay, so I can port 32-bit OS as well as 64-bit OS. Okay, so build root supports all the hardware boards, all the target boards, whatever it is. A Jink board also it is supporting, right? Jink MP board is also supporting. So all the boards are supported by the build root to develop the embedded Linux. Okay, so I'm coming out from the board folder, board directory. Okay, cd double dot means we are coming out to the directory. Okay, so again I'm giving the ls means list of files under this build directory. So it contains different architectures also, right? Cd arc ls, all the related config files, related files, all will be presented in this arc folder. Okay, so if I see the cd linux, all the linux kernel related files will be resides in this one. Okay, cd I could come out, and next command is make. I want to make it for particular Raspberry Pi board, right? Raspberry Pi 3 or Raspberry Pi 364. Okay, so Raspberry Pi 364 means, so I'm selecting this one. Make Raspberry Pi 364. Make is a command for the default configuration. Config def config underscore Raspberry Pi 3 underscore hyphen 64. Okay, so this step is over. So these are the main folders. Whatever the under the build root, we should be this one. And next one will be the command called as Raspberry Pi 364 Pi 3 underscore 64 underscore def config. Okay, so here I'm giving the same name. So this name is also if we can't remember this name, I can choose this folder. I can select, right. So vi config dot in, all the configuration related. Okay, to open the file. So whatever the white color words are there, that will be related to the files. So blue color lines means so these are the folders, right? So I'm copying the command from the here. Default configuration for the Raspberry Pi 3 64-bit OS I want, hence default configuration file I could choose, right? So ls. So if you see this one, there is no file called .config file, right? So but here it is given as after default configuration, it is shown it as configuration written to .config file under build root, right? fdp es is our work directory in this session, right? So under this we have the build root. Under this build root we have the file named it as .config. How we can see the .config? Vi default configuration we can observe in this .config file, vi.config. So if you see the all the things, so hash prompt is nothing but hash, here hash symbol indicates the comments. Okay, whatever white color lines are there, these are will be enabled, and remaining all the things are disabled. If you observe this one, so host gcc compiler we are taking now. GCC compiler is nothing but here it will be all the things are will be enabled. Here architecture is 64-bit architecture. Memory management unit is y means enabled. Okay, is not set means disabled. Here hash prompt after this will be showing as blue color, no, it will be ignored. And what are the white color one and equal to y means which will be enabled. Arc 64 means 64-bit. So if you observe, ARM architecture is ARC 64, ARM 64-bit OS. So little it will follows the Little Indian and LP 64, Cortex A53 processor. CPU is Cortex A53. As I said that Cortex processor are of three types: Cortex A, Cortex R, Cortex M series. So this will be the Cortex A53 will be the CPU which will be used in the Raspberry Pi board, which will resides in the Raspberry Pi board CPU is Cortex A53. Okay. So remaining kernel related and package related, these are the Linux headers. Package related, all the packages, whatever they needed for the embedded Linux building, all the packages are also will be enabled. So all these things will be resides in the kernel itself. Okay, so Linux kernel DTS supported. Device tree system files will be nothing but DTC files, DTS. So DTB overlay also DTB is nothing but device driver DTB files are there. That is also will be enabled. We will be calling it as overlay support. Okay, all the packages. Okay, is it understood? So it is already written by the tool itself. Hence, I'm not saving escape. I'm pressing escape colon Q. Q means just quit. Without saving, I'm quitting from the exit from the file. Okay. So this will be the next thing I want to show. So some other configuration I want to make, right? So make menu config. That means whenever I want to do some other changes, so vendor or build root tool, which can be with the usage of default configuration, we can get some of the configuration, some of the features are enabled, some are the disabled, right? But I want to add some of the features like creating password, creating host name. So like that I want to create, right? So for that purpose I'm using this command calling it as make menu config. Okay, so by using make menu config means I need to select the already with the usage of default configuration. Some of the configurations already set, right? Target options means what is your target board related information. So target board is Raspberry Pi board. In that I can have the ARM related ARM processor is there, SoC chip is there. In that ARM series I want the 64-bit configuration, right? Architecture 64, that means 64-bit OS I want. That will follows the Little Indian. Or you know, so as an embedded engineer, or you know the Little Indian and Big Indian, right? So Little Indian, which follows the I selected as Little Indian in the default configuration. It is defaultly it can select as Little Indian, and target architecture variant is Cortex A53, floating point VF VFPv4 and MMU page size. So cache memory will be used as page size of 4 kilobytes and binary format after downloading. What is a ELF? So that can be selected as ELF format. If you want to choose one more type, so rather than Little Indian, if I want to choose one more type, I can select whatever I want. I could select either a big Indian or Little Indian. Also, I can select by default. It can be set it as ARC64 Little Indian. Okay. So exit. So next thing I want to describe the tool chain also. So tool chain, as I told that all the related libraries, glibc, and also so here you can see the C library glibc. Glibc will be enabled and enabled install glibc. Whatever the things we want, give bin utilities options, GCC compiler version, and whenever we want to compile the C program, so we want the GCC compiler, right? So GCC compiler by default it can be set it as GCC 12.x. If I want lower version, then I could select this one. Okay, so 12.x. Okay, so by default 12 is there. So I'm using the same thing. If I want to change one more than the GCC 13 version, I could select this one. So selecting the module, that means whenever I want to select any option, just press space bar, then it automatically gives a star symbol. That means that feature is selected. Okay. Build options, build options also, so some of the tools are available. So in this strip target binaries, already default settings only I'm using. I'm not changing anything here. System host name, instead of build root I want to print host name as VNR VJIT, right? So host name as VNR VJIT because for today's FTP, VNR VJIT is the host. So VNR VJIT as a host name, right? So instead of welcome to build root, system banner also I can change welcome to VNR. Okay. So password, I could, this is a password encoding version. Here I'm not changing anything. Just I'm pressing enter itself. So busybox tool is used for the to build the root file system. Okay. Here I want to create some password. Enable root login with the password. Okay. So here already default configuration it is set, but I want to give some password, right? So if I want to give the password as 1234. Okay. So okay. Here I'm not changing anything. If I want any further modification I can do, right? Here I'm using, as I told that here raspberry I'm using Raspberry Pi 3 64-bit. So with the default configuration it's all automatically it is set. Okay, there is no need of another configuration. If I want, I can choose, right? So kernel version, so kernel version custom tarball, so I could choose the various versions. If it is 5.10 or if I want the 6.6 latest version only, if I want, so then I could select. Okay. So next, build a device tree blob. So this DTB is nothing but all the device drivers, whatever the devices are connected to your Raspberry Pi board, all the devices which will be the enabled by you whenever we have the star symbol here. Otherwise no device will be selected. Okay, so if you observe this one, BCM2710 is the SoC chip will be placed on the Raspberry Pi 3B. This type of board contains BCM2710. So for example, this embedded Linux, it supports this SoC. Broadcom is the company name, and this is the system on chip on Raspberry Pi 3B. Okay, so this is also same supported as BCM2710 RPi 3B plus. 3B plus board is variant which is released in 2018, and 3B board is released in the 2015, I think. Okay, so like that, these boards are supported. Why? Because in the def config we selected as Raspberry Pi 3 underscore 64. Because of that reason, here automatically it will be set. Okay, target packages. So if I want the network related applications, for example, if I want to remotely, I could use, then the time I could use select this drop bear. Drop bear, if I select this one, then I could able to use this SSH command. Okay, like that. So if I want the real time applications, then I could select this one. Otherwise, if I don't doesn't want any real time responsiveness, then I'm not selecting this one. Why? Because unnecessarily choosing of features will take the more space on the image. Hence, whatever the needed one, that can be only the enabled, and remaining all are disabled. Okay, this is about the configuration. So it is asking for, while exiting, it is asking for if any saving of your configuration or not, right? So yes, click on yes. So it automatically gives a, you can come out from the configuration file. Okay, so now I'm using this make is a command to compile the kernel, right? So by using this kernel, so if you observe the make menu config, you can have all the configurations like tool chain. So what are the tool chain? Majorly you want the four components, right? What are the tool chains? So tool chain is one component, kernel is one component, and bootloader is one component. What else? Bootloader, tool chain. What else? Root file system. So I showed it as busy box. With that, I can make it use of root file system. Kernel I showed in this same command. So here tool chain, from this build root folder only I can get the, so whenever I'm making, I compile, I may get the tool chain, I may get the kernel itself, I may get the bootloader. Okay, so root file system internally, by using target packages, so by in this selection I could make use of busybox. Busybox will make the root file system for us. Okay, so exit. So here I'm using the command called make minus j11. So here j11, so my system processor, sorry, so what is my system? My system contains the 5.15 kernel, right? Uname minus M, x86 processor. X86 means general purpose desktop PC. Okay, this is a top command. That means what are the various processes are running on the desktop PC, that can be seen in this one. So in my system, I'm having the 12 processors. That means 12 processors. In the 12 processors, in the make command, I'm giving the, in the make command, sorry, make minus j n, where n indicates the number of processors. If your system contains the quad core processor, that means 4. If your system contains the octo core, that means 8. Okay, so 8 minus 1, j7 you can give. If my system, my system is having the 12 processors, 12 cores, hence I'm giving the number as j11. Then automatically the system is going to build the embedded Linux for develop for porting of embedded Linux onto the Raspberry Pi board. It will take minimum of 2 to 4 hours of time. Okay. So meanwhile, I'll show the slides where we are here. So as I showed, this one is I downloaded the build root, make menu config, make def config I used, and here make menu config I used, and later after configuration, that configuration I observed. Later make minus j11. So here what happened? All the standard Linux packages available as source code online. That means my system is connected through internet. Through internet, it will download all the packages whatever they want. It is downloaded from the internet itself. Okay, so next it will create the bootable image. Bootable image means dot image file it may ready. Okay, ready, and that will be copied into the SD card, and that can be put it in the Raspberry Pi board, and we can boot the Raspberry Pi board with embedded Linux, and we may going to use, right? So here that is the process. As I already developed the this one yesterday night, I developed, okay, FDP on the name of FDP. Okay, so here in this file, all these files earlier, some of the files are not there, but here after this, output folder is not available before making. Now in the output folder we have the images. Okay, in these in these images, SD card, this SD card dot image is required, and this can be copied into the SD card. This SD card dot image file can be copied into the SD card. Okay, these are the files, output files after make command. This will take 2 to 3 hours of time, no? So here you can observe all the script files can be downloaded. After that, it can take some of the time. So host ACL 2.3.2 is downloading, right? So like that, all the script files are downloading. After CC means cross compiling, downloading, cross compiling. So this process may continues for 2 hours or 3 hours of time. Okay, so later you may get this folders and files in the output folder, right? Output slash images. You can observe this one, SD images. Okay, so this SD card image can be booted by using Baleno HR tool. Okay, so before that, I'll insert some module. That means SD card I'm going to insert. So this one, this is a SD card, SD card. So 8 GB SD card, I'm placing it in the SD card holder. So that SD card holder, I'm putting in the laptop USB port. Then it may going to recognize by using. So whenever any additional device is going to connect, right? So I'm giving clear command to clear the screen. Okay, so LSBLK, whenever SD card is connected, so it is showing it here. For example, as I already ported yesterday night, okay, so 32 MB for this one, media engineer, and some of the ID it is showing as 9098 hyphen A306, that is shown as SDA. Your SD card will be, so if I put one time, it is shown as SDA. Okay, yeah, if I removed and I'm placing back to the same port, it is shown as some other name, the like SDB. Okay, so sometimes it may change. Okay, so here what is the size of your embedded Linux image size? 32 MB, 120 MB, right? So if I want to write using the with a new image, if I want to write with a some software tools I may use, right? So for example, here in this place, Baleno HR, like Pi Imager tool, we have this tool is Baleno HR tool. So Pi Imager can only support the SD card image. This Baleno HR is having some other features which will copy the any sort of any format it can accept, and it is going to flash it on the SD card. That is the main advantage of Baleno HR. So even for Acto project, for placing Acto related embedded Linux onto the Raspberry Pi board, Pi imager is not supported. Hence, we are using the Bala nature in the industry. Okay, Bala nature. So here, flash from file. So flash from file. I'm choosing the folder, right? So what things I need to this one. So are you observe? Balanacharya contains only three steps. Here, first flash from file, which so here I need to select the image, right? I need to select the image. So the image will be in the resides in the FDP, right? FDP build root folder in output images SD card image, right? Open. Here I'm selecting the SD card. 8 GB SD card here. Are you able to see this one? 8 GB SD card. So flash, click on the flash. It is asking permission. Most okay, I'm giving the password and is ready to flash that SD card image. It takes few seconds to write the embedded Linux, that is SD card dot image img file onto the 8 GB SD card. Okay, if you observe the file size, so this is your SD card image. This is only the embedded Linux image, right? So if you observe the size of the embedded Linux size, operating system size is how much? 159.4 MB. That is the size. That means very less in size when compared with the Windows operating system size, Linux operating system size. This SD card dot image, this only one image is sufficient to put the embedded Linux onto the Raspberry Pi board. Okay, if you observe the slides, if you observe this one, disk space for Ubuntu installation, 15 GB space is required. Empty space is required, right? Disk space for Windows 10 installation, 16 GB for a 32-bit, 20 GB for 64-bit OS is required. So if you put embedded Linux onto SD card, how much space it is occupying? Only 150 MB. 150 MB means so small. Okay, so in embedded Linux, memory is so constrained, so limited. So hence, we are porting operating system features within a little space, that is 150 MB. Okay, so flash is completed. That means operating system is put in embedded Linux SD card dot image is entirely ported onto the SD card. Hence, I'm closing this one. I'm removing the SD card. I'm placing that SD card into the this one. And one more thing I want to show here. So after copying SD card image into the SD card, it is showing as I'm placing the SD card into the I'm doing hardware connections. I placed the SD card into the Raspberry Pi board. So here, minicom ISS. Is that command we are using for the serial communication? Sudo minicom minus s. It is asking some permissions. Serial port setup. If TTY USB, where it is connected, we don't know, right? So then you can give some command called sudo dmessage minus w. So this is a command. We can get the kernel printouts on the console itself. Okay. So here you can observe that at the last line, whenever you enter the dmessage command, dmessage minus w. So here it is shown as UART converter. UART converter now attached at the TTY USB 0. Okay. So whenever here we need to give in the minicom terminal, I should give this number. So SD card is ported and it is shown as root password 134. Okay. So this will be the terminal belongs to CD belongs to Raspberry Pi board. So Raspberry Pi output we are seeing in the Unicom terminal. Okay, CD slash, that means root file. Under root directory, whenever we are entering the ls. So that means, yeah, it is showing as all the root file systems here: bin folder, lib64, Linux RC, media related, opt, whatever the root file system while I explaining, I showed some diagram, no? So all the folders I can have it under the root directory. Okay, if you observe if you press the uname or host name here, host name we are given as VNR widget, right? So host name, so yesterday I get given as VNR, right? Host name, and the machine related information I can get by using the uname minus m. That is a ARC64. I built the embedded Linux for ARM processor, ARM architecture, 64-bit OS, right? So uname machine name is ARC64. Okay. So I connected the if config. So I connected the Ethernet cable. Hence, I want to know the IP address of my Raspberry Pi board. If config. So this is my IP address. IP address of Raspberry Pi board. Okay. So like that you can create any number of files. So any commands like a desktop, we can execute any command here, but only build root supports the command line interface, not the GUI. Okay, graphical user interface is not supported by the build root operating system. So in a router setup boxes, we doesn't want any GUI kind of thing, right? Hence their build root is used as embedded Linux in for embedded applications where GUI is not required. There we may going to use build root build system to develop the embedded Linux for applications, application development. Okay. So if I want to execute any commands, that means if I want to execute cross compiling, I'll show how the cross compilation may happens here. Okay. So here I connected the Raspberry Pi in this manner. So Raspberry Pi contains the GPIO pins. So it contains the 40 GPIO pins. Under the 40 GPIO pins, so I'm connecting. So that means I'm communicating within the same laptop. I'm showing as Raspberry Pi output also, right? So Raspberry Pi output, that means Raspberry Pi is connected through serial USB to serial converter to the laptop. In this way I connected. So SD card slot, and the SD card slot I put it the I placed the SD card at this SD card holder of Raspberry Pi. So I connected in this manner. So later, It is showing Unicum terminal as I already showed this one, right? So demessage terminal. So if we connected any hardware peripheral to the Raspberry Pi, Unicum terminal also in the Raspberry Pi. So here demessage to the Raspberry Pi board. Okay, so it requires permission d message dem sg minus w. Oh, sorry, the message. If you observe the last line of demessage terminal, that means kernel print, you can observe this last line. That means mouse is connected to the next uname minus a. So if you observe Linux kernel, latest kernel only I ported. That is a 6.1 series kernel series I ported, and it is ported at the last night. So that is a 250. Okay, 24, 14th. So early morning only I ported. So architecture name is ARC64 GNU Linux. That means 64-bit OS for ARM processor. Embedded Linux is built, and that will be dumped under the Raspberry Pi board. Okay, so host name VNR, right? So just I want to show the welcome message also here. Just I reboot the Raspberry Pi board. Just I switch off the Raspberry Pi board and I reboot it, right? So whatever in the kernel configuration, whatever I wrote, welcome to FDP on embedded systems, it is displayed as welcome message. Later, VNR login, it is asking if I press the root. Root is the username and password is 1234. Okay. Later, all the commands. If I want to execute any C program here, okay, what is the procedure and how we can execute and all I will show now. Okay, so now compilation already you know that Turbo C compiler already used, right? Cross compiling. So now I want to discuss about the cross compiling. Cross compiling means this is the host PC. So on the host PC means x86 host PC that is running on the Linux, that is running with Linux, Debian or Ubuntu OS. Okay, so which is source code, libs means libraries. So cross compiler. Cross compiler means normally cross compiler any C program you can run by using the GCC compiler only itself. But we are cross compiling the C program for some other target platform. That means some other board. For example, Raspberry Pi board. Hence, we are using ARC64 GNU tool. I'm using as cross compiler. Okay. Finally, it is going to finally this ELF binary format. File format is this one. Okay. ARM ARC64. That file format can be only acceptable for this Raspberry Pi board. Then output can be observed from by using this Raspberry Pi board. Okay. So this will be the procedure. So before using the class compilation, first we need to install the all the packages. Okay, all the packages. I'm going to connect this one. First, I need to install all the class compiler related on host PC. So I have to install GCC make GCC ARM Linux GNU EABI. So all these related kernel related files can be uh, cross compiler related tools can be installed in the host PC. Later, so I'm taking the simple program, include stdio.h, simple, very simple program. This is just a hello pi. It is going to print the hello pi. Okay, so how will be the cross compiling? So normally compilation means cc file name hello pi.c. That's it. we can get the data whenever we want to know the output, dot slash a dot out is going to execute. But whenever we are want to cross compiling, it is another issue. This means this command we need to give. Okay, I'll go to the normal terminal of desktop, cd ftp. Okay, ls. Okay, so in this already I have written some program called hello.py.c. hello.py.c. Okay, simple two line, 5 lines of code, right? So just it is a command comment. I included the header file stdio.h into main. Just one printf statement I am given as welcome to VNR VJIED. Just that's it, right? So this file I want to compile, and I want to cross compile it for ARC64, and I want to cross compile it for our ARM 32-bit version also. Okay, how it will be done? I am going to show that one, and I am going to wind up the session, right? So CC, see just CC compiler hello pi dot c space. Okay, already have the command, right? So hello pi x86 means just output file is saved on the name of hello pi x86. Okay, executable file minus o hello pi x86 dot slash. I want to execute the command, right? Hello program I want to execute. So compilation is done, and now I want to show the output of hello pi.c program, right? Hello pi x86. So whatever the command I had given, welcome to VNR VJ, right? So output is printed as welcome to VNR VJ. Clear? So next one, I want to cross compile. I want to cross compile by using this command. So what is that command? Command called I want to make the I want to do cross compiling same hello pi.c program for ARM 32-bit architecture. So here I'm given as ARM Linux GNU ABI is a cross compiler tool chain GCC. Till this is the cross compiler tool, and hello pi.c is my program, and minus o is nothing but object file. Hello pi ARM 32 is the 30 for 32-bit OS. It is a executable file name. So static means statically linking dynamic libraries are statically linking here. So I'm executing this one ls, sorry, dot slash. My file name is hello pi underscore 32. Whatever I'm giving here, arm 32. So arm 32. So it may not going to print the welcome to VNRBIT at this place. Why? Because it is cross compiled for some other architecture. So this terminal is belongs to only desktop PC. That is my laptop terminal only. Hence, it is not showing. So if I copied this file into the SD card, there I'm able to show the output. Okay. So there I'm able to get the output. So for that, I'm going to copy this uh, executable file into the SD card in the root partition, root file system. root directory. I need to copy. Thereafter, I can execute from the Raspberry Pi terminal. Okay. So class compilation but for the ARM64, this is the command ARC64. ARC64 is nothing but 64-bit kernel, 64-bit kernel, 64-bit embedded Linux OS. I am going to use this command. So remaining command is same. Okay. If I want to know the file type, so here I already developed this command. No, so executable file it is developed. No, so this file hello pi x86. If I want to, this is developed for x86, right? So file command is used to get the information about the file. What is the type of binary file? So file is a command to know the type of the file. Okay. So in this way, we need to copy the after generating the executable file after class compiling. I may have the hello pi underscore arm32, hello pi underscore arm32, and arm64 also I can copy onto the SD card in this portion. That means in the root directory I could copy. Thereafter I can have execute the commands. So finally I could conclude that what are the feature of embedded Linux global market. So in the global market, there is so much of importance of embedded Linux. Why? Because IoT applications are going to increase nowadays. Hence, all the embedded applications, all the embedded gadgets are used, especially use the embedded Linux. Why? Because it will produce security and it offers more security. It offers more reliability and it will be available with a lesser cost. Why? Because embedded Linux is an open source. So it should be used in the edge computing also, and integration with AI and machine learning. For this also, embedded Linux is used, and real-time capabilities. So embedded Linux can also be used for real-time applications by choosing that configuration and all, and which will be very customization and flexibility. And these are the some of the references from this official websites only you can download, and you can make it in your own embedded Linux for your target board. Okay, any questions? Any questions? I hope it is understandable for everyone about embedded Linux. Can anyone respond? Thank you.
వెల్కమ్ టు ఏబిఎన్ బిజినెస్ న్యూస్. దేశీయ స్టాక్ మార్కెట్లు నష్టాల్లో ప్రారంభమయ్యాయి. సెన్సెక్స్, నిఫ్టీ నష్టాల్లో కొనసాగుతున్నాయి. కోల్ ఇండియా, హిందాల్కో, రిలయన్స్, భారతీ ఎయిర్టెల్, హెచ్సిఎల్ టెక్ షేర్లు లాభాల్లో ట్రేడ్ అవుతున్నాయి. ఇటు బజాజ్ ఫైనాన్స్, విప్రో,